Hello friends, we have to continue our standard 9th unit number 5 acids, bases and salts. In this chapter we have seen about the ionic compounds. That is, ionic compounds, there are three types: acids, bases and salts. Also, ionic compound, they have two main constituents, that are cations. Ionic compound has two main constituents, that is cation means positive ions and anions, that is negative ions. So these are the main constituents of ionic compounds. Now today we have to learn the topic, that is ionic compounds and electrical conductivity. So today we have to learn the topic, that is ionic compounds and electrical conductivity. Now in this topic, you know about the ionic compound, what is ionic compound and what are their constituents. So ionic compounds, they can conduct electricity. Ionic compounds, they can conduct electricity when they dissolve in water. When they dissolve in water, as they will dissociate into their ions. See, when these ionic compounds are dissolved in water, then they dissociate into their ions. And that ions have an ability to conduct electricity. So we know different ionic compounds. See, salts, strong acids and strong bases. These are all ionic compounds. See, here is one diagram is also given. That is sodium chloride and copper sulfate. These are the salts. So examples of ionic compound, that is salts, sodium chloride and copper sulfate. These are ionic compounds. In strong acid, we know the strong acid, that is sulfuric acid, that is H2SO4. It is a strong acid. And strong base, that is sodium hydroxide. So salts, strong acids and strong base, these compounds dissociates completely in their aqueous solutions. So these compounds dissociates into their aqueous solutions and there is a formation of ions, and hence they are electrically conductors, or they are electricity conductor. So these ionic compounds are electrically conductors because they dissociate or they dissolve in water and they will dissociate into their ions that having the ability to conduct the electricity. Now we have to take one example which is shown in this diagram, that is ionic compounds and electrical conductivity. You know about what is ionic compounds and how they are able to conduct the electricity. Now we have to take one example. See what is given in that example. First, there is one activity given for this. First, prepare a solution. You have to prepare a solution. See, prepare a solution of 1 gram sodium chloride in 50 ml water. See, 1 gram of sodium chloride in 50 ml of water. So you have to prepare the solution which contain 1 gram NaCl and 50 ml of water. So in this beaker we have to take that solution. Now take two electrical wires, connect that wires. One wire is connected to the positive terminal of the battery. See here, one wire is connected to the positive terminal of battery and another wire which is connected to the negative terminal of battery having 6 holes. So in this case we have take one battery having 6 volt capacity and two wires, out of which one is connected to positive terminal and another is connected to negative terminal. See, these two wires which works as an electrode. Now you know about the electrode, that is electrode connected to the negative terminal of battery are called as a cathode. See, these two wires which acts as an electrode, out of which first which is connected to the negative terminal. So this acts as a cathode, and one connected to positive terminal which acts as a anode. Now there is one bulb having switch. So you have to construct this apparatus in this way that is shown in the chart. Now after that, remove this insulation of the wire about 3 cm from the free end of wire. That is, free end of wire, you have to remove their insulations up to 3 cm. Now you have to take salt solution in this beaker, that is 50 ml of salt solution we have to take in a beaker, and then you have to immerse these two wires, in this solution, and both ends of two wires have straight, so you have to given a support. See here, support is given. Then switch on the current as you have given a battery. Now next step is you construct this apparatus in this way, and after that you have to switch on battery. Then when you switch on the current, you have to observe whether this bulb is glows or not, and repeat this same procedure with using solutions of 1 gram copper sulfate, then 1 gram glucose, 1 gram urea, then 5 ml of dilute H2SO4, 5 ml of dilute NaOH, and you have to record your observation in given table in your book. So in this way we have to observe this activity with different solutions. Now first we have to make this aqueous solution of this sodium chloride, aqueous solutions of sodium chloride. Then we have to construct this apparatus, that is wire, battery, bulb, switch. In this way we have to arrange this apparatus. Now we have to observe what happens after we have to switch on or off. So in aqueous solutions, the compounds, that is sodium chloride or copper sulfate, sulfuric acid, or NaOH, that is sodium hydroxide, these are all ionic compounds, and we see that these ionic compounds, they are having the ability to conduct the electricity. So in this case also, when we have to form aqueous solution of this given compounds, then they dissociates completely in water. So when we have to add 5 gram of NaCl in this water, then it dissociates completely in water, and there is a formation of ions. And we know that there are two types of ions, that is anion and cation. So anion, that is, you know that anions and cations having positive charge and anions having negative charge. So after dissociation there is a formation of ions, that is cation and anion. Now cation having positive charge, they attract towards the cathode having negative charge, and at the same time anions, that is negative ions, they are attracted towards the anode. Having positive charge. So negative charge attracts towards the positive electrode, and positive ions which attracts towards the negative electrode, that is cations are attracted towards the cathode and anions are attracted towards the anode. That is this movement of ions. So there is a movement of ion, and this movement of ion in the solution, it forms, or they have a ability to conduct the electricity through this solution. So electrons conduct the electricity. They conduct the electricity through the wire, and ions they conduct the electricity through the liquid of the or solution. So in this way there is a conduction of electricity, and due to that electric circuit is completed and electric current is flow through this bulb, and that bulb glows. And another example, if we have take aqueous solution of glucose or urea, these are not form ions. In these solutions there is ions which are not formed, so electric circuit is not completed, and hence the bulb does not glow in the aqueous solution of glucose or urea. So in this way we have seen this activity. So you have to complete the given table in your notebook. So this is our first point, that is ionic compounds and electrical conductivity. Now our next point, we have to take our next point, that is electrolysis. So our next point is electrolysis. So you have to write the definition of this electrolysis. What is meant by electrolysis? So first we have to see the concept of electrolysis, and then we have to take example also. So electrolysis, next point is electrolysis. So what is electrolysis? Listen, it is necessary for the liquid solutions to have a large number of dissociation ions for the electrolysis to take place. That is, for electrolysis, the aqueous solution requires a large number of ions. Then, so substances which undergo dissociation to great extent, so the substances which undergo dissociation to a great extent in the liquid state, they are called as a electrolyte. So this is the concept electrolyte. That is, they have a capacity to form a extent number of ions in solution. So these substances are called as a electrolyte. Then salts, strong acids and strong base, they are electrolytes because they form large number of ions in solution. So electrolytes, that is salts, strong acids and strong base, they are a good conductor of electricity in their liquid or solution state only. So salts, strong acids and strong base, these are known as electrolytes and they are a good conductor of electricity, but their state is liquid state or a solution state only. Now electrolysis, in another way we have to define this electrolysis. That is, electrolysis is the dissociation of an electrolyte, that is salts, strong acids and strong base. So electrolysis is the dissociation of electrolytes into ions at the electrode by the passage of electric current. So in this way we have to define this concept, that is electrolysis. Now we have to take one example also on this electrolysis. So we have to take the example, that is electrolysis of water. So our next point is electrolysis of water. You have to write the point, that is electrolysis of water. In exam you have to ask question, that is explain what is mean by electrolysis of water and write electrode reactions and write their electrode reactions. We know that electrodes, positive electrode and negative electrode. Positive electrode which is known as a anode and negative electrode which is called as a cathode. So we have seen that concepts earlier. Now we have to take example, that is electrolysis of water. So our point is electrolysis of water. So in this chart there is a diagram of this electrolysis of water. Also I will send a video on this ionic compounds and electrical conductivity on this topic as well as on electrolysis of water after this lecture. So coming on point, electrolysis of water. So when electric current is passed through the water, see, when electric current is passed through the water containing few drops of acid or few drops of base, then it dissociates to give H plus ions and OH minus ions. So what happens in this? See, when electric current is passed through the water which contains few drop of acids or few drop of base, what happens then? Then it dissociates to form H plus ion and OH minus ions. Then hydrogen gas is formed near the cathode. See, near the cathode hydrogen gas is formed, and towards the anode oxygen gas is formed. Towards the cathode, hydrogen gas is formed, and towards anode, there is a formation of oxygen gas. So this is called as a electrolysis of water. Now this is the concept of electrolysis of water. Now we have to also write the reactions at electrode. So we have to write reactions. So at the cathode, what happens? We have to see here. As water dissociates, it forms ions, that is H plus ions and OH minus ions. So after the dissociation of water, there is a formation of H plus and OH minus ions. Now what happens at the cathode side? See, cathode having negative charge, cathode which means negative electrode, and we know that positive ions are attracted towards the negative electrode. So in this case, positive ion is hydrogen, which attracts towards the cathode. Then what happens? See, at the cathode, what happens? Hydrogen ions attracts towards the cathode, and in this case, this hydrogen ions, hydrogen ion gains electron from the cathode, and there is a formation of hydrogen. So hydrogen is migrate towards the cathode and gain electron, and it becomes neutral. So neutral hydrogen is formed, but this hydrogen is not stable, so it combined with another hydrogen. This hydrogen is not stable, so it combined with another hydrogen and form hydrogen gas. So in this way, at the cathode, there is a formation of hydrogen gas. Then we have to see the reactions on the anode side. So now at anode, what happens? Anode, that is positive electrode. So in cathode, we have seen that positive ions are attracted towards the cathode, and in anode, what happens? The negative ions, that is OH minus ion, which is attracted towards the positive electrode, that is anode. So in this case, which reactions occur? We will see here. See, at anode, what happens? Hydroxide ion, it gives electron. See, in cathode, what happens? It gains electron, and at anode side, what happens? It gives electrons, and so there is a formation of OH, which is not stable. So it added with another OH or hydroxide ion. So what happens here? This OH, another OH, and hence after addition of this another OH, what products are formed? Hydrogen plus oxygen. But this oxygen, see, this oxygen is not stable. So it will add with another oxygen, then oxygen plus oxygen, then there is a formation of oxygen gas. So in this way, at anode, there is a formation of oxygen gas, and at cathode, see, at cathode, there is a formation of this hydrogen gas. So this is called electrolysis of water. See, in this chart there is also reactions which are given here, that is cathode reaction and anode reaction. We will see on this board also. This is easy way that you have to write these reactions, that is at the cathode there is a formation of this hydrogen gas and at anode there is a formation of oxygen gas. So this is called electrolysis of water. So in this way we have completed our topic, that is acids, bases and salts. Now you have to solve exercise of this topic, and at the same time you have also solved the questions which are given in your textbook. That is after every topic there are some questions given and you have to solve that questions also, because that questions are important. Now after this I will send 2 videos, that is Ionic Compounds and Electrical Conductivity and Electrolysis of Water. So on this topic there are 2 videos which I will send after this lecture.
Electricity conduction in ionic compounds. Make a circuit as shown here and insert the electrodes and add sodium chloride. Switch on and observe. You will observe that the bulb glows. The NaCl solution dissociates into sodium ion and chloride ions. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions which move to the opposite electrodes when electricity is passed through the solution.
Electrolysis of water. If electricity is used for decomposing a substance, it is called electrolysis. When electricity is passed through acidic water, it decomposes into oxygen and hydrogen gases. But water is a bad conductor of electricity. Therefore, a little salt or a little alkali is added to water for easy conduction of electricity. Dissolve a little quantity of acid in water. Pour the solution in an apparatus as shown here. Fill 2 test tubes with solution and see that no air bubbles are present. Invert these test tubes over the iron nails. These are called electrodes. Connect these outer electrodes to the positive and negative terminals of a battery. You can see that gases are produced in the 2 test tubes. After 30 minutes, examine the volume of each gas formed in the test tubes. Are the volumes of gases equal? Introduce a glowing splinter into the test tube in which less amount of gas is formed. The splinter burns brilliantly. Therefore, we can say this gas is oxygen. Introduce another glowing splinter into the test tube in which more volume of gas is formed and observe it. This splinter is put out with a pop sound. But the gas burns with blue flame. Hydrogen possesses this property. Therefore, we can say that the gas present in this test tube is hydrogen. In this way, sending electricity through water and decomposing into oxygen and hydrogen is called electrolysis.